All right, let's pick it up from where we left off last time. Where did we leave off? I think we did 173 and 174. Don't remember doing 175. Okay, so let's have a look now. I wonder if my trick would be useful again here. A point P moves around the circle. The measure of the angle changes. The measure of how fast the angle is changed is called the angular speed omega and is given by that formula. So let's make that first. Omega of theta and t, that's defined as theta over t, where theta is in radians and t is time, presumably in seconds. Find the angular speed for the given data, round to the nearest thousand. Okay, so omega, and let's see what the first one is. 7 pi over 4 and 10 seconds. Okay, so let's calculate that. Oops. Okay, let's calculate that. Okay, actually I can check the answer. 175. Oh yeah, and we have to get it to the thousand, don't we? So that would be 0.549, so 550 radians per second. Okay, so that's the first answer, and that is correct. Excellent. Okay, let's have a look at the next one. Next is the 3/5 3 pi over 5 and 8 seconds. And let's get that now. So that would be 0.236 radians per second. Let's check if that's right. Yep, it is. Okay. The next one now, C, is 2/9. And almost caught me out there. 1 minute. So 60 seconds. Okay, so that is 0.012 radians per second. Let's check that one. Oh, that's kind of funny because I presumed they want the answer in per second because that's usually the unit for um, angular speed, like radians per second. So let's read the question again. It's weird. They did it per minute. I mean, it's the same answer, just a different unit. So if we want to keep it as per minute, then it's just going to be 2 pi over 9 per minute. You're just dividing by 1. I don't know. Should that not be per seconds? Really, honestly? Radians per minute? I really don't agree with the answer here. if you kept it as units of minutes, that's 0.698 radians per minute, which I must point out I really dislike. So it's going to be the same issue in the last one as well, because it's going to be 23.76, and then it's 14 minutes, so 14 times 60. So for me, I really want to say it's this 0.028 radians per second. But again, or if you do it per minutes, then it's just going to be 23.76 divided by 14, which is 1.697. Which again, I have to point out that I dislike. Okay, so anyways, those answers match up, bar unit difference with what's in the back. And I know I've said it many times, but I don't know. The normal unit for angular speed is radians per second. So anyways, let's move on now to 176. A total of 250 square meters of land is needed to build a nuclear power plant. Suppose it's decided the area on which the plant to be built is a circle. Find the radius of the circular land. So the formula, as you know, is pi or squared. That should equal 250,000. And I don't think anything will happen if I just run that. But what I can do is type solve %01. I think this should do the trick. Yeah, obviously we don't want the negative answer here, so we'll just go with or we'll just type in 500 divided by square root pi. Now, do we want the exact answer or the approximate answer? Well, I want to leave it like this. That's the exact answer. But if you're wondering, the approximate answer would be that. That would be the radius. So about 282 meters. That would do the job. Okay, so that's the first part done. If the land area is to form a 45% sector of a circle instead of a whole circle, find the length of the curved side. So 45-degree sector is basically an eighth of a circle. So I just have to change the equation a little bit, I think. We can just say 1/8 times pi times r squared. That should equal 250,000. Then we want to solve that. So it should be a bigger radius. Solve %05. Yeah, that's a bit messy. So that's what the radius should be. But they don't actually want the radius, we want the arc length. And the arc length formula is r times theta. So that would be the radius, which is %07 times the angle. 45 degrees is pi over 4. So if I calculate that, about 200 pi, and let's get that to numeric, about 627 meters. Okay. Okay. I think that's okay. Now on to 177. Sorry, I'm not writing the question numbers down, am I? Should be doing that. 177. Okay. Put this up. Make sure I'm still recording sound. Yep. Okay, 177. The area of an isosceles triangle with equal sides of lengths given by that formula, where theta is the angle formed by the two sides. Find the, okay, so area formula, and it uses x and theta. Theta, where are you? That is defined as a half times x squared times sine theta. And find the area of an isosceles triangle with equal sides of length 8. So that's 8 inches. And an angle of 5 pi over 12. Okay. Oops. I thought it would be okay with that, but it wasn't. Okay, that's the answer. Let's make it numeric. So that's about 31 inches squared. I actually have the answer there since it's an odd one, 177. Okay, they do one decimal place. Okay, that's fine. Right, now 178. Particle, okay, let's clear this off there. A particle travels in a circular path at a constant angular speed omega. The angular speed is modeled by the function. Okay, so omega t is defined as, oh, now how do I do absolute in maxima? 9 times ABS perhaps? Absolute of cos pi t minus pi over 12. Let's see if that worked. 9 cos pi t minus pi over 12. That looks okay. Determine the angular speed at 9. Okay. 9. Bum, 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 bum. Okay. This should be a positive. Okay, so that's about 8.69 radians per second. Okay, 179 now. See, I started opening up tickets for a couple of mistakes I noticed in the previous sections, but I feel like at this point I'll just be spamming them. Like, for example, in 179, it never actually says in the question, but the t is in seconds. So, I mean, I could say that, but I really think I feel like I'd be spamming at this point, so maybe I shouldn't. Okay, 179. An alternating current for outlets in the home has a voltage given by this function. Voltage P is defined as 150 cos 368t. And time is in seconds. Find the period of the function and interpret its meaning. Oh, okay. I don't have to do anything here. The period is 2 pi over 368. What is that? Okay. So that means basically one full cycle of voltage will be completed in about 0.0171 seconds. Wonder what they say at the back. Yeah, okay. Repeats every. They didn't round it this time. They kept it as pi over 184. Yeah, that's fine. Okay. And interpret its meaning, right? Determine the number of periods that occur when 1 second has passed. Okay. Okay, so it's just going to be literally 1 divided by the answer. Now let's use the exact answer, which is on %02 line. So let's just get a numeric there. Okay, so about 58 periods per second. In other words, it is running at a frequency of 58 hertz. Now let's see what they say at the back. Approximately 59. 59. Wake up, Stephen. Well, actually, no, because the reason I said 58 is it never completes it's in the middle of the 59th one. So actually, I didn't want to round up. So if you round the answer, it's about 59. So how about we compromise and we instead say nearly, but not fully, 59 cycles are completed in 1 second, meaning it is nearly running at 59 hertz, but not quite. That's the important thing. I didn't like actually rounding that one up because in my mind it's in the middle of the 59th one, so I didn't want to round it up because it made it. Anyways, doesn't matter. Okay. Okay, only 3 questions left. Okay, that's good. 181. 180 now. Okay, so let's type this formula in for the number of hours of daylight. NT equals 12 plus 3 times sine. 12 plus 3 times sine. Then there's a 2, and then there's a t minus 79. And then there's a 2 pi over 365. And those brackets have been messed up now. Okay, let's see if that looks right. Right, NT is 12 plus 3 sine 2 pi over 365, t minus 79. Find the amplitude and the period. Okay, well, the amplitude is 3. And the period is the 365 because it's 2 pi over 2 pi over 365. So, yeah. Okay. days, obviously, and this is hours if you want the units. Okay, let's just... Okay, and now next, determine the number of hours of daylight on the longest day. Oh, well, that's just 12 plus 3. I don't even need a calculator for that. That's 15. And now it's going to ask for the shortest. Yep. And the shortest will be 12 minus 3. That's 9 hours. Okay. Determine the number of hours of daylight 90 days after January 1st. So that's just N90, isn't it? Okay, let's see what that is. Let's get numeric, of course, to make the answer human understandable. About 12.5 hours. Sketch the graph of the function for one period. Okay, now I forget. How do I do that? Will I just copy this over? Would that be the safest thing to do? Okay. 0 to 365. And then the y goes from the shortest to the longest, 9 to 15. Will that work? Oh, it didn't like that. Okay, so I have to change the letters. It's not T. I should put y equals here. Okay, let's run this again. Okay. So that's what the graph looks like. I can add in more details like x and y axis, but you can see here, you can see there, that's, what's that, December 23rd? And then it starts the uptick after that. But at the start of the year, January 1st, it is still kind of low number of daylight hours. And then this would be, what's this now? The summer solstice, isn't it? Sometime in June 21st, is it? That looks about right. So yeah, that's the shape. So I think that's okay. Yeah, okay, that's good. All right, 181. Okay, so suppose t equals 50 plus 10 sine, and in the first bracket is pi over 12, and the second bracket is t minus 8. Is a mathematical model of the temperature in Fahrenheit at hours after midnight. Determine the amplitude and the period again. Okay, well, it's not much to do here. The amplitude is 10, and the period is 2 pi over pi over 12. So it's 24 hours. Right, 2 pi over pi over 12. So the pi's cancel. It's just going to be 2 over 1 over 12, which is 24. So there's no need for a calculator there. Find the temperature at 7 hours. Okay, so let's just get that there. And the temperature at 7 hours is needs to be numeric. Make it human readable. About 47.4 Fahrenheit. Okay, and then well, what time does it equal 60? Okay, so when do we get 60 here? That is at 14 hours. So the time would be 1400 hours. And then sketch the graph again. Okay. Let's just copy that. Okay. So it's not, I should have changed that last time. It's t from 0 to 24. And that graph goes from 40 to 60. There it is there. Whoops. Where'd it go? Dips down, starts rising at what, about 2 a.m. Reaches its maximum before 3 o'clock. Okay. Oh, this has answers, doesn't it? Oh, I think I like my graph a bit more. It's not so stretched out on the y-axis. Anyways, that looks fine. Okay, so now 182. Okay, function now, h of t is 8 times sine pi t over 6. H is height in feet of a tide t hours after midnight, assuming that t0 is midnight. Find the amplitude and period. Oh, this again. Amplitude is 8. Period is 2 pi over 6. So that's 12. And graph the function over 1 period. Let me just skip that for the moment. What is the height at the tide at 4:30 a.m.? So what's the height at 4.5? That's 4:30. Okay. Let's just make that human readable. Height of the tide's about 5.65 feet. Now I'll plot it. We'll do a 1 period plot? Yeah, so that's 0 to 12 hours. And the height is from kind of weird because it's not really height per se, I guess. It's more displacement because the height can be negative here. Like it drops 8 and rises 8. So kind of feel like we might need a bit of clarity on that last answer. So I think what I might prefer to say here, percent 05 plus 8. Keep doing this. Percent 05 plus 8. So I think I'd rather say it is about 13.4 meters above its low tide. I think to me that makes more sense. Again, I don't want to spam them with suggestions, but I know what they're trying to do here. It's simple harmonic motion around the equilibrium. But yeah, I think I would express that height at 4:30 a.m. as being about 13. Why did I say 13.4? What is with me with rounding today? 13.7. Come on. 13.7 meters above its low tide. Yeah. -8 to +8. So there's a, yeah, okay. Yeah, okay, good. I think we'll wrap things up there. I mean, we're finished the exercise. That's really nice. Can check that answer. As always, if you spot a mistake, please do so in the comments, and I'll try and fix it if I can. Thanks for watching. Oh, I went quite a bit over today from what I planned.